So in chapter 3, section 6, it's talking about asymptotes. And so most of you have probably seen vertical and horizontal asymptotes in a pre-cal class. When you're looking for a vertical asymptote, those are the values that make your function undefined. So when you set your denominator equal to 0 and then solve. So on this one it would be positive 4. So if we set x cubed minus 64 equals 0, we would get positive 4. And so we see that horizontal or vertical asymptote here. The horizontal asymptote is something that's, with rational functions, we can pretty much determine by looking at the degree of the polynomial on top and on bottom. And so they have some rules in the book that are pretty standard. If the degree of the numerator is less than the degree of the denominator, then it's 0. If they're equal to each other, you go by the coefficients, the leading coefficients of each polynomial. And if the degree of the top is larger than the bottom, then it does not have a horizontal asymptote. There's also the case where you could have slant asymptotes, but I don't think we dive into that too greatly. Like this one has a slant asymptote. But these are basically the rules where they have asymptotes. They also have some ways of doing it with limits, but for vertical and horizontal asymptotes, I would kind of use those pre-cal ideas. So in number 2, again, your vertical asymptote, which makes the denominator equal 0, and your horizontal asymptote, since the degree of the bottom is larger than the top, we'd get a horizontal asymptote of y equals 0. So this is our horizontal asymptote. You cannot cross a vertical asymptote, but just for future reference, you can cross a horizontal asymptote. Looking at something like number 3, they're looking at limits, and we've done one like this previously, but as we're going to 3, like we could just plug 3 in on this one. It doesn't make our denominator 0. There's nothing bad about it. And so that's how we could get some of our answers. Looking at number 5, the degrees are the same on top and bottom, and so these are when we're going to infinity. That's where we find our horizontal asymptotes. So as we go to infinity, since the degrees are the same, we're just looking at the ratio of our leading coefficients. And 5 over 25 gives us a nice 1/5. So I would advise just kind of graphing these, looking at the picture, but use those rules for vertical and horizontal asymptotes. Vertical asymptotes is when the denominator equals 0. Horizontal asymptotes is you look at the degree of the polynomials for numerator and denominator. Number 6, similar again, as we go to infinity on this one, since my degrees are, this one's larger on top than on the bottom, so this one does not have a horizontal asymptote. This one would be a 4, but we have something that's going off to infinity and something that's going to 4, so 4 plus infinity kind of gives you the idea of it's still going to infinity. Also on Desmos, just an FYI, if you type in infinity, you get the infinity symbol. So, but this one, no supplement really needed. Just some of these basic rules and some rules from the past.